right, well, if you notice, we skipped section 6, and here we are at section 7, where we're talking about circles that are in the coordinate plane. So that means you guys are going to get to do some graphing. Yay! But before we start talking about the circle in particular, I just wanted to kind of give you a brief overview of what conic sections actually are, because a circle is a conic section. So you can kind of see from this picture, if I had two cones, kind of one on top of the other where their vertices match up, and then I took a plane and I sliced through the cones, depending on the angle that I have the plane tilted at, the slices would create different shapes, and those shapes are called conic sections. So in the first diagram here, the plane is parallel to the base of the cone. And when that happens, you slice it off and you get a circle, a perfect circle, because a cone's base is a perfect circle. But the second you start tilting this plane just slightly, it creates an ellipse, which is an elongated circle, or sometimes we call it an oval. So you can see how I've kind of tilted the plane a little bit, and then you get this kind of flattened or squished circle. Now, if you take your plane and you tilt it just far enough that it intersects the cone or slices through the cone at an angle where it just keeps going and going, so like you've tilted this so far up or so far down that it just keeps going for infinity and beyond, that's where we get that parabola. And you might have heard about the parabola in algebra when you did quadratics. We are not going to be talking about the parabola today. That's for next year when you get into Algebra 2. Now, the most extreme case is if you were to take your plane and angle it in such a way that it actually intersects both cones. So you might have been wondering, why are there, these two cones for these three when we only sliced through one of them? Well, that's because if you did take your plane and slice it through to intersect both cones, you would get the hyperbola. And the hyperbola kind of looks like two parabolas that are kind of opposite each other, going in opposite directions. They're not actually parabolas. They have their own special, unique qualities and characteristics to them. And that's something that you'll explore in pre-calculus when you get there. So like I said, today we're going to talk about the equation of the circle. And later on, if we have time, we'll talk about the ellipse as well. And we'll save the parabola for Algebra 2 and hyperbola for pre-calc. All right, so let's get into it. Because we're talking about coordinate geometry, we have an actual algebraic equation that goes with the graph of that circle. This is what it looks like. It looks very complicated, right? There's a lot of pieces to it. But anything that we graph on the coordinate plane needs to have an x and a y, because we have the x and y axis, right? That should make sense. But the h and the k and the r, those are all parameters that when you plug those in for like numbers instead of h, k, and r, it's going to change the look and the position of your circle. So depending on whatever these values are, you could get a really big circle, a really little circle. It could be at the origin, it could be at a different center point, it could be shifted all over the coordinate plane. So the h and the k represent your center values. The h is the x coordinate and the k is the y coordinate. And you can see how h matches up with the x and the k matches up with the y. This is universal. This will carry on throughout the rest of your math classes that you take. So the sooner you can kind of get that hardwired into your brain, the better off you'll be. And then R stands for radius, which we're used to having that stand for radius, right? Okay. One key thing is that you need to understand the h value here that you see, it's whatever you would plug in for x to make this quantity 0. Right? So if I plug h here, h minus h is 0. Same thing for k. K minus k would be 0. So the thing is that we're going to be given a center value and a radius, and we need to plug these numbers in right now. So if I plug it in, the 2 is h, the 5 is k, and the radius r is 6. Now I'm not going to multiply all this out before you start freaking out on me. We're just going to leave it like that. The only thing we're going to do is actually multiply the 6 times 6 to get 36. But I want to point out this interesting relationship, and this is what trips up students all the time, even in Algebra 2. This is a positive 2, and this looks like a negative 2. This is a positive 5, this looks like a negative 5. And like I said, this value 2 is what you would plug in here to make this 0. So if this is x minus some number, that's going to be the opposite. Like this 2 and that negative 2 is going to be the opposite sign. If this is positive 5, then this is negative 5. And so we always think of it as being the opposite sign than what we think it would be. Okay, so let's try another one. Write the equation of the circle with the center at the origin and the radius of 3. So if the center is the origin, remember the origin has the coordinate 0, 0. So that means h is 0 and k is 0. So when we go to plug that in, x minus 0 squared, and then y minus 0 squared, and then 3 squared. Well, the thing is that we don't typically write x minus 0 or y minus 0. We clean that up a bit, and we just call it x squared plus y squared equals 9. So don't let that confuse you. I know for some reason when the origin is a 0 or you don't see any parentheses here, you don't know what the center is, it makes it more difficult. It's actually supposed to be a lot easier for students. So just don't let that trip you up. The origin is just 0, 0. So if the center is the origin, it's a very simple looking equation. Okay, so now that we kind of have that, let's talk about graphing these things. So here's my first example. We have x squared plus y squared is equal to 25. State the center and the radius, and then we have to graph the circle. So the center, what do you think the center is? Hopefully you guys said the origin, 0, 0. And what do you think the radius is? I'm hoping you guys said 5. Okay, so now that we have that information, how do we translate this information into a picture or a graph? Well, the first thing I'm going to do is I'm going to plot the point that's the center, which is the origin. And then with the radius being 5, what I'm going to do from that center point, I'm going to count out 5 units in every direction, right? And I put those points. So I need to have these 4 points surrounding the center of my circle. And it's just a matter of counting up 5, to the right 5, down 5, and to the left 5. And then you're going to do the best you can. I know you don't necessarily have a compass at home, and you don't need a compass to make these circles. You can just freehand your circle by connecting the dots to try to get your circle. Now, of course, I did it on a computer, so it looks perfect. But if you did it by hand, I want you to actually try your best to make it look like a circle and not make it look like a square. So every year, I always have students that draw circles that look like this. And you might be laughing, yes, that looks like a square. But that's them saying, oh, I just have to connect the dots, right? But you need to actually try to curve this to make it look like a circle. So don't do what I have here in gray. Try your best to make it look like the blue. Okay, let's try another one. So this is where, going back to what I was talking on that last slide, trying to pick out what the center is when it's not the origin. And you have to look at the 3 and the 1, right? But this is a positive 3, and this is a negative 1. So I've always told students, I'm like, just change the sign when you pull it out to figure out what your center is. So if I change the sign of positive 3, that would give me a negative 3. And if I change the sign of negative 1, I would get positive 1. But if that doesn't make sense to you and you don't remember that, go back to the thing that I said before of these values are what you plug in for x and y to make this 0, right? So I'd have to plug in a -3 for x to make this 0, so that's why this is -3. And I'd have to plug in a +1 here to make this whole thing 0, so that's why that's a +1. And then your radius, hopefully you said was 4. Okay, so now I'm going to plot my center, and then I'm going to count 4 units in each direction, and then I'm going to connect the dots to get my circle. All right, moving right along. Next example says, here's my equation. Is the point -3, 2 actually on the circle? And so the way that you can figure this out is by plugging in the x coordinate of -3, where you see x here, and the y coordinate of 2, where you see y here. And when I plug that in and I work it out, so I'm going to subtract these and subtract those and then square them, I get 5 = 5. So because this gave me a true statement, the answer is yes, point A is on the circle. All right, and then the last example here, it says write the equation of a circle with the center at 2, 4, and passes through the point -3, 1. So they gave us our center, which is h and k. So I can plug that in, x minus h squared plus y minus k squared, but we don't know what r is. So that's what we're looking for. So once again, they've given us a point, which is an x and a y value. So this x being -1, I can plug that in here. And this y being 3, I can plug that in there for y. And then I can solve for r squared. You don't have to solve for r, we just want r squared, right? So just add these together, subtract them, square it, subtract these, square it, figure out what you get, and you get r squared is equal to 10. So once you know r squared is 10, go back to this part of the equation that you already had. All we have to do is replace the r squared with 10, and we got our equation. Okay, so that's it. Sorry, once again, a very long video. Talk to you guys later.